Relationships in mathematics can be quite compelling, and in this case we're going to look at multiplication as it advances to division and finally multiplying binomials. When we have our hundreds plate here and 5 of the tens rods and 6 of the blues, the student's objective is to simply construct a rectangle. There are many ways that we can construct that rectangle, and we'll follow a conventional construction of that rectangle. We'll put 2 of our tens rods here, and at the base we'll put 3. And that leaves in the lower right corner the space for the 6 ones. 1, 2, 3, 4, 5, and 6. Now that we've completed our rectangle, let's take a look at its dimensions. Across the top we have 12. We have 10, 11, 12. And so let's go ahead and put up a 12. From top to bottom we have 10, 11, 12, 13. So let's go ahead and identify that as 13. When we move these two factors now to the side, put in the multiplication symbol and the baseline, the students are going to be immediately familiar with this and the algorithm, but we're going to accomplish this algorithm a little differently than they have in the past. We'll take a look here and asking the students where they want to start first. Typically they will want to start with the hundreds plate, and that is 10 by 10. So asking the students what in here gives us the 100. And of course it's the 10 times the 10. So we'll put in the 100. That takes care of the red hundreds plate. But where do we go next? Anywhere you want. So that the 6 blue pieces, that is 3 times 2. We'll put in the 6. Our 20 comes from our 10 times our 2. And likewise our 30 comes from 3 times 10. And so now that we have our partial products, or expanded notation, we have all of the components, we can begin to consolidate our numbers so that we have 106, it's simply the red and the blue added together. We can bring in our 30 more closely, we can take out our 0 here and put in our 30, 136, 136. Let's bring in our 20, they want to add together, and that gives us 50. For finally, 156 or 100, 10, 20, 30, 40, 50, and 6 for 12 times 13. Where do we go from here is to division. 80% of your construction is now completed, and you simply provide a dimension here of 12. I'll put a little space between the array so it's 12 there, and along the side from top to bottom I place my 13. I match my sides. The divisor, the dividend, and the quotient give us an illustration of how now we take apart the area. Bringing the area together, that is called multiplication. Breaking that area down, our divisor breaks down the dividend, and our quotient is 12. Watch as we take the divisor across the array, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 groups of 13. Now that we've completed our division of 156, we can take a look at the division of 158. With 2 remaining squares that don't make another strand of 13, they are the remainder, or represented as remainder 2. What else can we do with the remainder? We can put it over our divisor so that it's 2 over 13, or 2/13, that fractional remainder. The last interpretation here is to look at it algebraically. X plus 2 times x plus 3 is x squared plus 5x plus 6. Let's look at that again. X times x is x squared, units times x is 2x, 3 units times x is 3x, and 3 times 2 is 6, for x squared plus 5x plus 6. The conceptual layering between multiplication, division, and multiplying binomials allows students to see the network of connections in mathematics, which is critically important.